आज हम कंप्लीट करेंगे ब्लॉक 1 का यूनिट 3। ब्लॉक 1 का यूनिट 3 में पीडीएफ का देख लेते हैं। पहले पढ़ना क्या क्या है। इंटर प्रोसेस कम्युनिकेशन एंड सिंक्रोनाइजेशन। इंट्रोडक्शन। ऑब्जेक्टिव। इंटर प्रोसेस कम्युनिकेशन में शेयर्ड मेमोरी सिस्टम, मैसेज पासिंग सिस्टम। इसके बाद इंटर प्रोसेस सिंक्रोनाइजेशन, जिसमें है सीरियलाइजेशन, म्यूटेक्सेस, critical sections, Descartes solution of mutual execution, Bakery's algorithm, semaphores, classical problem in concurrent programming, producers customer problem, readers and writers problem, dining philosophers problem, sleeping barber problem। ये सारा किसमें क्लासिकल प्रोग्राम्स इन कॉन्करेंट प्रोग्रामिंग, लॉक्स, मॉनिटर एंड कंडीशन वेरिएबल समरी। ओके objectives, interprocess communication, shared memory system, message passing system, direct communication, indirect communication। This is about process synchronization, how multiple program means processes work together without messing each other up when they are shared resources like memory, files, printer, etc. Key ideas. What is concurrency? Concurrency means multiple program can run at the same time. Concurrency means multiple program called processes can run at the same time or same time. Example, in an airline reservation system, many people book tickets at the same time from different computers. Each terminal runs its own little program and all of them run together. This is concurrency. Okay, many people book ticket at the same time from their different computers. Each terminal runs its own little program and all of them run together. What is synchronization? Why synchronization is needed? These processes may share data or use the same resources like memory or printer. If they are not properly managed, they can change data in a wrong way, crash the system, print wrong results. How do processes work together? Processes can communicate. One process sends message to another, share data. They use a shared area of memory so both can read and write. Wait for signal. One process waits until another process says okay, now go. Interprocess communication, IPC. Interprocess communication. Two main ways process communicate. Shared variable, they both access and change the same data. Okay, shared variable, they both access and change the same data. Messaging, message passing, they send message back and forth like text chatting. Why synchronization is hard? Processes run at different speeds and you don't know what exactly when each one will do something. So we need rules to make sure things happen in a correct way. Synchronization tools. Some tools used to solve this problem. Tools, semaphores, a variable that control access to resources. Monitor, a way to manage which process can access data. Message passing, a method where processes talk to each other. Critical section, a part of code that only one process can use at a time. Summary: multiple processes can run at the same time. Concurrency: they may need to work together. Cooperate: they avoid conflicts. We use synchronization. OS use like semaphores, message passing, monitor to make this work safely. What is interprocess communication? Interprocess communication is how two or more programs talk to each other or work together. Why is क्या है? Interprocess communication is how two or more program talk to each other or work together. Interprocess communication से talk communicate and interprocess मतलब how two or more program talk to each other or work together. Why is IPC needed? In modern computer, multiple programs run at the same time. This is called multi-programming. This program often need to share resources like printer or files. IPC helps them to communicate safely without causing problem. Like both printing at the same time and mixing up data. Example: shared printer. Let's say two process A and B wants to use the same printer. The printer is a critical resource. The print command in A and B is the critical section. The system must ensure only one process uses the printer at a time. This is called multi-task execution. Okay. If both use it at a time, it prints out. The printouts may get mixed up. That's bad. Important terms explained simply. Critical resources: a shared thing that must not be used by two processes at the same time. Critical section: the part of program that uses a critical resources. Multi-task mutual execution. Okay. Mutual execution: only one process at a time can be in its critical section for the same resources. How do processes communicate? There are two main ways for processes to communicate. Share memory. No, okay. Processes. How do processes communicate? There is two ways for processes to communicate: share memory, message passing. To share memory, both processes can access the same part of memory. It's fast but need careful synchronization to avoid errors. Processes send message to each other. Safer but usually a bit slower. These two methods can be used together in one system. Older systems like DOS did not support IPC. Newer systems like Windows use feature like dynamic exchange (DDE) to let program talk. IPC lets different programs communicate and share resources safely. Without IPC, processes may crash or mixed up data. Two common ways: share memory and message passing. IPC also helps with synchronization, making sure things happen in a correct order. What is this section about? Okay, this is about interprocess communication, how different programs running on the same or different computer talk to each other and work together, especially when sharing data or resources. There are two main ways IPC can help: share memory and message passing. Same thing, yeah. Share memory system. Process share a common part of the memory. Shared memory system. Process share a common part of memory. They read and write to the same memory to execute information. It's fast but risky. Problem: race condition. If two processes try to read and write at the same time, the final result may go wrong depending on who acts first. This is called a race condition. We need mutual execution to stop this. It ensures that one process uses the shared memory at a time. Message passing system. Processes don't share memory, instead they send message to each other. The operating system manages this messaging system. Two key actions: send and receive. Send a message, get a message. Send, process message, receive, get a message. To work, you need a communication link between processes. How link can be made? Ways to set up communication: direct communication. You name the sender and receiver clearly. Example: send to process P, receive from process Q. Symmetric: both know each other. Asymmetric: only sender needs to know the receiver. Indirect communication, mailboxes. Messages go through a mailbox. Indirect communication, which is mailbox, messages go through a mailbox, a shared inbox. Any processes can put message in or take them out. Type of mailboxes: owned by a processes, owned by the system, only the processes can receive from it, and owned by the system, independent, any processes that permission can use. Message buffering, how messages are stored. Communication link can store message temporarily like a queue. There are three types. Zero capacity, message must be received immediately, sender must wait. Okay, zero capacity type में zero capacity, messages must be received immediately, sender must wait. Bounded capacity, only a limited number of message can wait. If full, sender must wait. If full, okay, only a limited number of message can wait. If full, sender must wait. Unbounded capacity, unlimited message can wait, sender never waits. Type of messages: fixed size, variable size type messages. All messages must be same size, easier to manage, harder to program. Variable size, easier for programmer but harder for system to manage. Typed messages, each mailbox can only hold a specific type of message. What is interprocess synchronization? When two or more processes work with the shared data, unpredictable result can occur. Correct. Example: two threads updating the same variable at the same time. Race condition. Goal: serialization, making sure processes take turn when accessing shared data so the results are predictable. Two main strategies: disable the scheduler temporarily, use a protocol. Disable the scheduler temporarily prevents other processes from interrupting during a critical operation. Not efficient for multi-CPU, multi-processor system. Use a protocol rules. Program must follow rules to access shared data safely. Work well on multi-processor system. The programmer is responsible for following the rules. The OS just provides tool. Mutexes, mutual execution. The mutex is a tool used to ensure that only one process can access the shared resources at a time. Two processes want to use the same printer. If both print at the same time, jumbled output. Mutex ensure only one process prints at a time. Issue with mutual execution. Deadlock. Processes wait for each other forever. Lockout, starvation. One process is never allowed to access the resources. How mutex works in code. Just leaving this part. इसको छोड़ते हैं. Critical section. A critical section is the code where shared data is accessed or updated. Characteristics. It reads or updates variable that other threads may also change. It uses or modified shared data structure rules. Only one thread process should be the critical section at a time. Bakery's algorithm. Imagine there's a bakery with many customers. At the entrance there's a ticket machine. Each customer press a button and gets a number. Okay. There's a bakery with many customers. At the entrance there is a ticket machine. Each customer presses a button and gets a number. Customer waits for their turn. The customer with the smallest number goes first. This is exactly how bakery's algorithm work in computer program when many processes wants to access the same data. Problem. Many processes wants to use shared data. Example: suppose three people, P0, P1, P2 wants to use a printer or update the same file. If they are try to do at the same time, it creates error. This is called a race condition. So we need to allow one process at a time to access the shared data. This is called a mutual execution. एक बार फिर से पढ़ते हैं. Suppose three people wants to use a printer or update the same file. Okay. If they all try to do at the same time, it creates error. This is called race condition. So we need to allow only one process at the time access the shared data. This is called mutual execution. Bakery's algorithm idea. Each process picks a number like a token. The processes with the smallest number go first. If processes get the same number, the one with the smallest process ID wins. If two processes get the same number, the one with the smaller processes ID wins. After using the resources, like the process put the number back to the zero. Shared variable. In this skip करती हूँ मैं. Step by step. Okay. Summary in one line: Bakery's algorithm is like taking a token number at the soap. The person with the smallest number get to use the shared thing first. Okay, the person with the smallest number gets to use the shared thing first. What is semaphore? अच्छा. Semaphore have to semaphore. What is semaphore? A semaphore is just a special variable used to control access to share resources like a printer. A semaphore is a special variable that is used to control access to share resources. Think of a semaphore like a traffic light. Green, you can go. Red, you must wait. Why do we need it? In multitasking system, multiple processes and threads might try to access the same resources at the same time, which can cause error or unexpected result. Semaphore help manage who can access what and when to avoid problems like race condition, data corruption, deadlocks. Semaphore simplified. Semaphore help manage multiple processes safely like a tool to control access, share resources. Definition: a semaphore is an integer variable used for synchronization. A semaphore is an integer variable used for synchronization. It uses two atomic operations, wait and signal. Wait and signal decrease the value if s is less than 0. Decrease the value. Block if waits, which is divided by s, is less than 0. Signal s increase the value. Unblock a waiting process. Semaphores are powerful but can make program hard to understand, like using go-to in program. Let me know if you, okay. This is explain what's written on the book. When many processes run at the same time, they often need to communicate and share resources. Using normal variables for the communication is confusing and risky. Semaphores provides a better and more organized way to control this. Semaphores are like go-to. Just like an old go-to statement in early programs, semaphores can be used to many tasks, but they don't give much structure, can be hard to understand without any comment. So in modern system, more structured tools are developed to use the semaphore. A semaphore is a special integer variable that is used to process synchronization. Make sure the process is running in order and don't interface with each other. Semaphore operation: atomic happens all at once. Wait, also called P on down. If s is greater than 0, decreases s by 1 unless the process count time. If s is smaller than equal to 0, process is blocked. It has to wait. Signal, also called V and up in case. Semaphore helps to solving problem like mutual execution, process synchronization. Classic problem in concurrent programming. Producer customer problem idea. One process in producing data, others process in using the data. Another process using the data. Producer customer program. One process is producing data, another process is using the data. A buffer box is between two temporary hold item. Two types. Unbounded buffer, no size limits. Producer can keep producing forever. Customer waits it. There's nothing to consume. Bounded buffer. Real life example: a cook. Producer prepare foods and put it on the counter. A cook producer prepare a foods and put it on the counter. Buffer, a waiter picks it up. If the counter is full, the cook waits. If it's empty, the waiter waits. Readers writers program. If some processor only want to read data, some processors want to write data, which is risky problem. If one is writing, no one should access the data. Multiple readers can read the same time, but writing must be exclusive. Real life example: think like a Google Docs. Many people can read it at once. Only one should edit it at a time. Writer or content become inconsistent. Only one should edit it at a time, or the content could become inconsistent. Dining philosophers program. Readers dining philosophers program. 5 philosophers are sitting at a round table. Each needs 2 chopsticks to eat. Okay, but there are only 5. Each needs 2, but there is only 5 chopsticks. Problem: if all philosopher picks up one chopsticks and wait for the next, nobody can get eat. Okay. Real life example: imagine 5 people sharing 5 forks to eat. Each grabs one fork and waits for another. That's sleeping barber's problem. There is one barber in a limited waiting chair. If there is no customer, barber sleep. If there is a customer and there is a free chair, he waits. If no chair is free, customer leaves. If the barber is sleeping, customer wakes him. Think a barber shop. If it's empty, the barber sleeps. If many customer comes, some must wait. It's too crowded. Some customer leaves. Once again इसका हम पढ़ लेते हैं. Classic problem of concurrent programming. पहला है producers customer program. Real life: a cook prepares a food, put it on the counter. A waiters pick it up. If the counter is full, the cook waits. If it's empty, the waiters wait. Readers writer problem. Real life: imagine 5 people sitting and eat this. Each grabs one fork and waits for another. They are stuck forever. Sleeping. Barbers are sleeping. Okay. What is lock? A lock is a tool used to control access to the shared resources. A lock is a tool used to control access to the shared resources when multiple processes or threads want to use it at the same time. Goal: to make sure that only one process at the time can access the critical section, the part of the code that uses this shared resource. Think of it like imagine a bathroom with a key. Only one person can take the key and go outside. Think of it like imagine a bathroom with a key. Only one person can take the key and Only one person can take the key and go inside, acquire the lock. When they are done, they return the key, release the lock. Other must wait until the key is available. Monitor and condition variable simplified. What is monitor? A monitor is a special kind of module or package that groups share data. Producers. Okay. procedures that operates on the data and the synchronization automatically handle. Think of a monitor like a secure room where only one person can enter at a time to safely work on shared data. Unlike raw semaphores and lock, where you manually write code to manage locking, unlocking, the monitor hides the complexity from the programmer. Why monitors? When using semaphores and lock, forgetting the unlock and signal can cause deadlock or bugs. Monitor makes it easier to avoid such mistake by automatically handle locking before entering and procedure inside the monitor, unlocking when the procedure is finished. How does a monitor work? You can declare shared data and procedures inside the monitor. Whenever a process calls a producer inside the monitor automatically lock accesses, runs the procedure, then release the lock when done. Block 3 में बस इतना ही था. What is race condition? How race condition occur the operating system? Summary लिखा हुआ है, पढ़ लेते हैं एक बार. Interprocess communication provides a mechanism to allow process to communicate with other processes. Interprocess communication system is best providing by a message passing system. Message system can be defined in many different ways. If there are a collection of cooperating sequential processes that share some data, mutual execution must be provided. There are different methods to achieving mutual execution, different goals available for the section problem, which we have discussed in the unit. The bakery algorithm used to solving the processes. Interprocess synchronize provides the process to synchronize their activity. Semaphore can be used to solve synchronization problems. Semaphore can be accessed through two atomic operations can be implemented efficiently. The two operations are waits and signal. There are number of classical synchronization problems which we have discussed in the unit producer customer. These problems are important mainly because they are example for a large class concurrency control in the aspects of deadlocks. Block 3 हो गया, block 4 next.